So today I will be doing exercise 13.30. The question is, an Earth satellite moves in a circular orbit at a speed of 5,500 meters per second. What is its orbital period? So I just drew this picture of the Earth and the satellite. So two things to note is the speed in which it's going in, and as well as the circular orbit. So it's moving in a circular orbit. So for circular orbits, we use these two equations, which is the velocity equals square root gravitational constant, the mass of the Earth over the radius, and the period is the period squared, which is equal to 4 pi squared over the gravitational constant, the mass of the Earth, times the radius cubed. So first thing, just note what you know, which is we know the gravitational constant, we know the mass of the Earth, and we know the speed it's going in. So we first want to start off with this equation. We want to solve for r, the radius. So I'm just solving for r right now. Okay, so when you plug everything in, you'll be left with 1.32 times 10 to the power of 7. And I'm just gonna eliminate everything in the end. So if you cancel things out here, you are left with 1.32 times 10 to the 7 meters. So that is our radius. So that's the radius from the center of the Earth to the satellite. So now that we have the radius, we are able to find the period. So now we're gonna solve for the period. And the equation is period squared is equal to 4 pi squared divided by the gravitational constant times the mass of the Earth, all that times the radius cubed. And that's the radius we figured out. So the answer will be all this square root, the square root of this. And you will get in the square root, your answer is this large number. Oops. And these are your units, which we will cancel out in a bit. So when you cancel things out, you're left with s second squared, which will be, the squared will be canceled out with the square root. So when you square root everything, you are left with 50,088 seconds, which is about 4.2 hours. So our final answer is 4.2 hours. So this means that it takes the satellite 4.2 hours to do one full orbit. So pretty much be where it began. So it takes the satellite 4.2 hours to get back to its initial point. And that is all.